Okay, so I want to walk through how we solve speed problems and acceleration problems. You should be taking notes on this as we go along. It's probably not a bad idea to even try these problems before you watch me solve them and make sure that you do this in the proper manner. So, Catherine sprinting all the way across the field and returns to the midfield mark. The field is 80 meters across and it takes her 15 seconds total. What is her speed? So if you want to just think about that logically, it's not a bad idea to draw that out. This field overall is 80 meters, and her motion brought her that way. So if you think about it, you'll be less likely to be tripped up if you actually can diagram a problem like this. She goes 80 and then she comes back halfway, so that's a total of 120 meters. That's the total distance that it took her. And if you look, it took her a total of 15 seconds. The formula for speed, if you look at the previous page, and you can look at these formulas on our Haiku page on the physics link, that formula is S equals D over T. S is speed, D is distance, T is time. So S equals D over T. Our D is 80 meters. Sorry, not 80, 120. My bad, 120 meters. Her time is 15 seconds. And you should then calculate what that value is. So if I'm doing that really quickly in my head, that should be, I believe, 8 meters per second. That's your answer for the first part. Now, the second problem, you need to use some of the information from the first problem. It says if she ran at her this average speed, sorry about my terrible grammar here. Catherine ran at this average speed for a full minute. How far would she go? Well, you have to use that 8 meters per second is her average speed, which is calculated, and you've got a full minute for the time. 1 minute. One of the problems with this is you've got mixed units. You've got seconds and minutes. Hopefully you all know that 1 minute is the same as 60 seconds. So what we're going to do is we're going to take this same problem. Let's go ahead and erase what we've got over here. Use different colors. Green. We're going to use S equals D over T again. S equals D over T. There are two ways you can go about this. You could plug your numbers in right now and rearrange it, or you could rearrange it and then plug in your numbers. I don't really care which way you go with this. So we know speed is 8 meters per second, so I'm plugging in first, then I'll rearrange later. The D, we don't know what the distance is, and then the question, because that's how far would she go, that's what we want to know. And then the time is 60 seconds, so 60 seconds. So to solve for that, we need to get D by itself, so you multiply both sides by 60 seconds. 60 seconds. Seconds cancel out. Seconds cancel out. The math you actually do is 60 times 8. That should give you, I believe, 480 meters, because meters are the only units that are left here. So that's your answer for part 2. She would run 480 meters if she was running at that same average speed of 8 meters per second the entire time. Okay, and then the last problem. Last problem, how long would it take her to run a 5K at this speed? Well, another thing you need to note here is that when they say 5K, they actually mean km, kilometers. A 5 kilometer race means that you're running 5,000 meters. So the things we know again in this problem are we know that she's running at 8 meters per second. Still, that's kind of unrealistic. He has to be running the same speed the whole time, but with that same average speed over that long distance, but it's numbers we're using. And we know that's our speed. We know the distance she's running is 5 km, which is the same as 5,000 meters. So notice that I translated into meters. Hopefully, can we see this on the video screen? Yes, we can. Because if we've got meters here, we need to be dealing with meters over here. So let's set up our equation. S is equal to D over T. And I plug those numbers in. 8 meters per second is equal to 5,000 meters divided by T, time. This one gets a little bit more difficult. This is kind of like that last acceleration problem we did before, that you're going to have to do a couple steps. You multiply both sides by T, because you want to get T on the top in the numerator. That cancels T out over here. So if I rewrite that, now it would be 8 meters per second times T is equal to 5,000 meters. To get T totally by itself, now we need to get rid of 8 meters per second. Well, notice we've got multiplication there. So you divide by 8 meters per second, divide by 8 meters per second. T is equal to 5,000 meters cancel out. So it's just 5,000 divided by 8 seconds. I'm trying to think of what that math is off the top of my head. I believe it's somewhere around 500. Give me 1 second as I actually figure it out. 5,000 divided by 8. 625. Okay, I was a little off there. So 625 seconds. Now you could, of course, translate that into minutes as well. If you divide it by 60 seconds, you should get that turns out to be 10 minutes and 25 seconds. And hopefully this is the point you realize that, holy cow, she is just smoking fast if she runs a 5K in 10 minutes and 25 seconds. We should be very impressed with her new world record for that time. Hopefully that helps you see how we can solve the 3 different types of speed questions. This one we calculated the speed, this one we found the distance, and this one we found the time. So hopefully you can apply these lessons on future problems.